Picture this. You're Ford, General Motors, or Volkswagen, industrial giants worth trillions of dollars. You've been setting the pace of the global economy for over a century, right? Your orders literally move mountains of steel and rubber. But then one day in 2021, you call to order some tiny chips that cost just a few dollars each, and you're told there's a waiting list behind a teenager buying a smartphone. Wait, what? How did century-old automotive empires end up begging for scraps from a Taiwanese tech company? And why did billion-dollar assembly lines come to a complete halt because of parts smaller than postage stamps? I'm Rishi Punchal, and we're diving deep into the most shocking industrial collapse of the 21st century. How the global auto industry discovered it wasn't as powerful as it thought. When giants fall, here's something that'll blow your mind. In 2021, Ford had thousands of their most profitable F-150 pickups just sitting in massive parking lots, almost finished but completely unsellable. Why? They were waiting on microchips smaller than your thumbnail, right? Meanwhile, in Germany, Volkswagen's main plant in Wolfsburg, the heart of their global empire, hit its lowest output since 1958. Think about that for a second. This is the same company that survived 2 world wars, multiple recessions, and countless crises. But tiny silicon chips brought them to their knees. The numbers are absolutely staggering. In 2021 alone, the auto industry lost $110 billion in revenue. That's billion with a B. Over 11 million cars were cut from global production plans. Some estimates show that between 2020 and 2022, the world lost over 35 million cars. 35 million. That's like every single car in Germany just disappearing. But here's the kicker. This wasn't some natural disaster or war that caused this chaos. It was a fundamental misunderstanding of how the modern world actually works. The perfect system that wasn't so perfect. For decades, the auto industry had what seemed like the perfect system. Just-in-time manufacturing, right? It's beautifully simple. Every part arrives exactly when needed. Never early, never late. No massive warehouses, no inventory costs, maximum efficiency. Toyota pioneered this, and everyone copied it because it worked flawlessly for mechanical parts. Steel suppliers could ramp up production quickly. Tire makers could add an extra shift. In the physical world, supply was flexible, right? The system worked like a perfectly conducted orchestra, with thousands of suppliers moving to the automaker's rhythm. But here's where everything went wrong. They treated semiconductors, the literal brains of modern cars, just like any other commodity. They applied mechanical supply chain logic to high-tech manufacturing. This was their first massive mistake. Making semiconductors isn't like running a steel mill, guys. Building a new chip factory, called a wafer fab, is one of the most complex and expensive projects on Earth. We're talking years of construction and billions of dollars. Even ramping up production on existing lines takes 3 to 6 months of prep time. You can't just flip a switch and make more chips, right? The great mistake of 2020. Now here's where the story gets really crazy. When COVID-19 hit in early 2020, automakers looked at the crashing economy and made what seemed like a smart business decision. They slashed production forecasts and canceled chip orders. To them, this was just good cost management, right? But for chip foundries like Taiwan Semiconductor Manufacturing Company, TSMC, this was a clear signal the auto industry was stepping back. Meanwhile, with everyone stuck at home, there was an absolutely historic surge in demand for consumer electronics. Laptops, webcams, gaming consoles, smartphones, sales went through the roof. So TSMC did what any business would do. They shifted every available production slot to their most eager and profitable customers: Apple, Qualcomm, Nvidia. The auto industry willingly gave up their spot in line, and tech companies were more than happy to take it. Then, boom! By late 2020, car demand came roaring back. Consumers had stimulus money burning holes in their pockets, but couldn't spend it on travel or restaurants, so they wanted new cars, right? Automakers frantically called their suppliers, but all they got was silence. Production slots were booked solid for the next 12 to 18 months. The 800-pound gorilla that used to boss around the entire supply chain suddenly found itself at the very back of a very, very long line. The brutal reality check. Want to understand just how powerless the auto industry really was? Let's look at this from TSMC's perspective, because the numbers are absolutely eye-opening. In 2020, when the shortage was peaking, automotive chips made up just 3% of TSMC's total revenue. 3%. Compare that to smartphones at 51% and high-performance computing at 31%. When automakers canceled orders, it was literally just a rounding error for TSMC. But when Apple or Nvidia asked for more capacity, that was strategic priority number one, right? Here's the thing most people don't realize. Not all chips are created equal. Before 2021, most car chips were what we call traditional chips, or microcontrollers. These are the workhorses that control your electric windows, manage airbag deployment, regulate anti-lock brakes. They're built on older, fully depreciated manufacturing processes. 45 nanometer, 90 nanometer, or even larger nodes. For car makers focused on cost cutting, these cheap, reliable chips were perfect. But for TSMC, these chips were just an afterthought, right? TSMC's focus, reputation, and profits come from cutting-edge chips, 7 nanometer, 5 nanometer, now 3 nanometer processes that power the latest iPhones and AI accelerators. The power dynamics weren't just about money. They were about innovation. The auto industry consumes yesterday's technology, while the tech industry drives tomorrow's breakthroughs. The new reality: cars as computers. But here's where everything changes, and why this crisis marked the end of an era. The forces reshaping cars today, electrification and automation, are completely flipping the script on who has the power, right? Traditional gas cars might have a few hundred to maybe 1,000 separate chips. But modern electric vehicles, they have between 1,500 to 3,000 chips. And it's not just about quantity. The total semiconductor value in an EV ranges from $1,500 to $3,000, roughly 2 to 3 times that of a comparable gas car. Cars aren't just machines anymore. They're software-defined, rolling data centers. By 2025, the industry is rapidly moving to centralized system-on-chip platforms. These aren't just chips. They're full-fledged supercomputers. Take NVIDIA's Drive Thor platform. This thing delivers up to 20 trillion operations per second and can handle massive AI workloads for autonomous driving. Or Qualcomm's Snapdragon Digital Chassis, a complete open platform that transforms cars into connected, updatable experiences, right? And here's the game changer. These automotive supercomputers use TSMC's latest, most sought-after manufacturing processes: 7nm, 5nm, soon 3nm. The same processes that power the world's most advanced smartphones and AI data centers. This completely flips the old power dynamics. In the past, car makers using 90nm chips and Apple using 7nm chips were in totally different worlds. But now, a new Volkswagen with Qualcomm's chips and the latest iPhone are basically ordering from the same high-end menu at the same exclusive restaurant. TSMC's cutting-edge fabs. Fighting back. The new strategies. The 2021 shock was a brutal wake-up call, but the auto industry isn't going down without a fight, right? They're completely rebuilding their approach from the ground up. Volkswagen, one of the hardest hit companies, is taking a brilliant multi-pronged approach. They've partnered with their software division, CARIAD, to co-develop custom chips with ST Microelectronics. But here's the genius move. They're requiring these chips to be manufactured by TSMC. This gives them direct influence and secured supply deep in the value chain. At the same time, they're buying high-performance chips directly from Qualcomm for their self-driving features. It's a smart dual strategy of custom development and direct purchasing, right? But perhaps the boldest move is the European Semiconductor Manufacturing Company, a €10 billion joint venture building a new wafer fab in Dresden, Germany. TSMC holds 70%, while automotive giant Bosch and chip leaders Infineon and NXP each own 10%. They're literally bringing production closer to home. Ford, determined not to repeat their F-150 disaster, has teamed up with U.S. foundry Global Foundries. Mercedes-Benz is signing direct deals with companies like Wolfspeed for critical silicon carbide semiconductors. The old linear supply chains are being replaced by complex, interconnected webs of strategic partnerships. Right? A dangerous game they're playing. But here's the thing about these bold new strategies. They come with massive risks that could backfire spectacularly, right? First up, the bullwhip effect. After years of shortages, everyone's locking in long-term, large-volume contracts. But what happens when this massive supply push meets weak demand? Analysts are already predicting possible oversupply by 2026 to 2027. Automakers could find themselves stuck with billions in non-cancelable chip contracts for chips they don't need anymore. Then there's the culture clash. Car manufacturers know mechanical engineering inside and out, but semiconductor physics and chip design, that's completely uncharted territory, right? The auto industry's development cycles are 5 to 7 years, with 0 defects as the goal. The semiconductor world moves at lightning speed with 1 to 2 year cycles. Ford CEO Jim Farley admitted their key mistake was not understanding the chip industry's technology roadmap. Bridging this knowledge gap means hiring new talent, building departments from scratch, and changing practices that have been in place for over a century. The ultimate vulnerability, but the biggest risk is something no company can control: geopolitics. The auto industry's new strategy actually increases dependence on TSMC and the geopolitical stability of the Taiwan Strait, right? Sure, TSMC is diversifying with new fabs in Arizona, Japan, and Germany, but these are hedges, not replacements. TSMC's cutting-edge R&D, highest production capacity, and unmatched ecosystem remain firmly rooted in Taiwan. Even TSMC's CEO acknowledges the huge challenges and costs of replicating Taiwan's capabilities elsewhere. Think about this scenario. If China were to blockade or invade Taiwan, it wouldn't just cause supply chain disruptions like 2021. For software-defined cars, basically data centers on wheels, it would be a catastrophic, complete shutdown. The brain of every advanced car would be trapped on an island, caught in a superpower conflict, right? This isn't just about cars anymore. It's about the intersection of technology, economics, and geopolitics in our interconnected world. Conclusion. So there you have it. The incredible story of how century-old automotive giants discovered they weren't as powerful as they thought. From treating chips like commodities to scrambling for silicon supremacy, this crisis revealed the new reality of our tech-dependent world. The auto industry's response has been bold and necessary, but fraught with risks. Whether they can successfully navigate this transition from mechanical manufacturers to tech-savvy mobility companies remains to be seen, right? What do you think? Are automakers making the right moves, or are they walking into an even bigger trap? Drop your comments below and let me know your thoughts. And if you found this deep dive valuable, follow me for more content that breaks down the complex forces shaping our world. Until next time.